I can tell you that we do live in an open universe, which means we're expanding out forever.
Right.
So there is no sight line that will come back to where we are.
Right.
It goes out.
Because the sight line is continually moving.
Correct. In a closed universe, the universe will recollapse so that a sight line, in principle, will ultimately come back. And the way to think about that is just the surface of a sphere.
Right.
We'll call it a perfect spherical balloon. We're all crawling around on the surface of that balloon, and
Don't look at me. I'm not the astrophysicist.
this is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. We're doing cosmic queries today, and that means Chuck is sitting right next to me.
Yes.
How you doing, Chuck?
Hey, what's happening?
Is this a topic, or is it
No,
grab
you
bag?
know what it is.
Oh,
It's galactic gumbo. That's right. That's right. Guarantee we won't give no in here. I'm gonna give him some. Put it down there. I'm gonna put it in pot. But there's no some guy on pepper.
didn't he die like 20 years ago? Paul Prudhomme? Is that his name?
his name? I don't know his name.
Have you seen him lately?
No, I have not.
And my boy was packing some weight.
I
back
haven't
then.
seen him in 20 years.
That's okay.
Oh,
Well, we thank him for granting you that accent.
damn that. That's right. That don't go see it.
So this is random, but they're all Patreon members.
Whatever they want.
But it's only Patreon members.
Correct.
Okay, I haven't seen any of these questions.
No, you
so-
do not get to see them. And I'm supposed to see them, but I'm lazy, so I don't see them either.
Okay.
All right, here we go.
Yeah.
This is Writer's Eye, who says, "Hello, everyone. I hope your day is filled with protons from only friendly stars."
Ooh. Well, maybe he meant photons.
Photons, yeah.
Did he say protons, or
It
did
said
you misread it?
No, it says protons.
You didn't misread
I
it.
did
Because
not
sometimes
misread
you and the reading
Listen,
thing.
I thought maybe
Reading is fundamental.
It is fundamental. No, I thought maybe he was, talking about like a pulsar or something, and so
Send the particles out.
sending particles out.
Okay.
But no, he probably did mean photons.
All right.
From Friendly Stars, he says, "How far are we away from being able to track gravity waves? I know we can detect them, so tracking them would be the next obvious step, in my humble opinion, that is. If we could track them, eventually we could map the universe edge to edge. Am I correct in thinking that?"
So a couple of things. First, a technicality.
Right.
The kind of waves made by,
Gravity waves by two colliding black holes.
okay, those are called gravitational waves.
Gravitational waves, right.
Okay, gravity waves is something else that acoustical people, is a term people use when they refer to a medium that's rising and falling in response to a pressure impulse that goes through it.
Right.
So those are gravity waves that they call. So we have to make sure that the kingdom is separated.
Right.
There, okay. The lexicographic.
Nice. the lexicographic reference has to be correct.
Distinct. So gravitational waves. So
Okay.
We detect them when they wash over us.
Right.
That's what LIGO did. That's what earned the Nobel Prize.
Right.
And you know who earned the Nobel Prize? Kip Thorne, who was one of the executive producers on.
Wait a minute. Wait, it's the string theory movie with Matthew McConaughey. It's called
Interstellar. Yes, good.
Yes.
So in fact, we took our crew out to Pasadena, where he lives, went to his home office,
Wow.
and interviewed Kip Thorne.
Very cool.
Yeah. You can find it on our archives. And he showed us his Nobel Prize.
Oh,
Dude, That was
wow.
cool.
You just keep that thing, huh? You
I know,
just
right?
Keep it around?
What do you do? Wear it on your
Yeah,
neck? What do
yeah.
you do? What else are you going to do with it?
I would take it everywhere.
Oh, yeah.
You know what I mean? You know, excuse me, do you know what time it is? I'm like, oh, excuse me, let me move my Nobel Prize out of the way so I can see my watch. How did that get there?
Where did that come from?
Oh, my goodness. Is that my Nobel Prize and where my watch should be? Oh, my goodness.
So here's what I learned recently, that yes, we can detect certain energy levels of gravitational waves that wash over Earth.
Right.
And there's certain other phenomena in the universe that do make gravitational waves that those detectors cannot see.
Okay.
Now, there's something I only know a little bit about here, so I just want to put it on the table.
Okay.
All right. That there's a research program that's going to be put into play that wants to detect the effect of gravitational waves moving across your field of view. So if you have a pulsar, which has very, very precise spinning rates, the most accurate
Set a clock by it.
You can set a clock by it, okay?
Right.
If a gravitational wave passes by it,
Right.
there's a change in the rate.
Right. You'll see the rhythm change.
The rhythm change just briefly.
Yes.
And so the idea is you monitor all the pulsars, you get their
Right.
rhythms known,
Right.
and then you see one change. And then you look to see if it
If it coincides with a gravitational wave.
well, that would be the evidence
That
of
would
one.
be them,
Now you
right.
see if it moves to the next one and then the next one.
Oh, right.
At the
And
speed
now
of
you
light.
would see the consistency across each pulsar.
Correct. And you'd be watching a gravitational wave
move across the medium of space.
Yes.
That's amazing.
Yes.
And
We're not there yet, but that's
unfortunately, we had to cut that.
what you start.
The funding for it's been cut already. We've saved so much money by not even thinking about it. You know it. I know it.
On that subject, let me remind you how much money NASA gets from the government.
What?
This is the space station, space shuttle, Hubble, JWST, James Webb.
Everything that NASA does.
Everything NASA does. We're going back to the moon.
Including looking
with-
back at
with
Earth and
Artemis.
weather and everything?
No, the weather would be NOAA.
That's NOAA. Okay.
Okay, but there's a strong collaboration between them.
The two of
Right.
them are.
Right. You know, it was like 10 years after NOAA was founded that I caught on that it's like pronounced like Noah, like Noah's Ark.
Like Noah's Ark, yeah.
Because he was the first weatherman. What do you think about
Oh my God. All right, so I'm just catching that
You
now.
just caught that now.
Just now, you had to actually spell it out.
Yes.
He was the first weatherman. Yeah. Hey, it's gonna rain. God says it's gonna rain, man. People are like, what are you talking about, Noah? What are you talking about? It hasn't rained. It has never rained here. Never. I'm telling you, man, I'm building a boat. It's gonna rain. Oh, crazy Noah, there he goes again.
So- Well, he did grow grapes, is my understanding.
He did.
And might have
And
made
he
some
did
wine.
drink.
Made a little
Well,
bit of wine.
the Bible references that he did drink.
Yeah,
Yes, but go ahead.
So the Noah,
By the way, if he did drink, I'm just saying, that's rough. Just like, I'll tell you right now.
it's going to rain.
The Lord spoke to me, told me,
Yeah, who's going to believe that? Right.
told me to get 3 of every animal. I think it was 2. Anyway, go ahead. Let's move on. All right.
So, of course, they spelled NOAH and then NOAA, National
Oceanic
and Atmospheric Administration.
Okay.
So, yeah, NOAA makes those. So, just to remind people
How much
that
money?
So, of your tax dollar,
Right.
it is 0.4 of 1 cent.
So it's not even a full penny.
Yeah. So you can say, I want to save money there,
Right.
but then what total impact is that going to have, given all the rest of the spending that's going on?
Right. It's not a very efficient means of cost cutting.
Yeah. So if you have a Department of Efficiency, it could be more efficient about where it's being efficient.
Right. I think we need to be efficient with the Department of Efficiency.
Exactly.
Right.
Okay.
All right.
Next one.
Here we go. Let's move on to Maurice van der Linden. This is Maurice van der Linden. He says, hey, Neil, hey, Chuck, I've been wondering about something Jana Levin said once in your episodes, that it might be possible that if you look far enough into the cosmos, your line of sight can loop around and the universe can end up at your position just along the timeline. Doesn't this imply that, if true, the universe is a perfect 4D sphere? You would see your past location, in your case, a young solar system, from every angle, so it would appear smeared out across the cosmic horizon. Love the show. Kind regards, Maurice from Haarlem in the Netherlands.
Oh, Harlem.
Yes.
Yes, Harlem. It's where we got our name, Harlem.
Harlem, here in New York.
Yeah, back when the Dutch were running.
Yeah. They owned it all.
They owned it all.
Yeah.
They put in all the canals because we have Canal Street.
Yes.
You know, and that's what they do.
Absolutely.
Even back then.
Nothing but canals.
So I don't know if I can answer it in the precision that
That
sought
he's talking
here.
about, right.
But I can tell you that we do live in an open universe, which means we're expanding out forever.
Right.
So there is no sight line that will come back to where we are.
Right.
It goes out.
Because the sight line is continually moving.
Correct. And out away from
And
us.
out away
All right.
from us, so there's no way that you could
Right.
loop back because
Okay,
it's
so
always going.
in a closed universe, the universe will recollapse so that a sight line, in principle, will ultimately come back. And the way to think about that is just the surface of a sphere.
Right.
We'll call it a balloon, a perfect spherical balloon. We're all crawling around on the surface of that balloon, and if you send out a beam of light, it will go away from you, but then come back and hit you in the back of the head.
Right.
Right? But that would be later.
Right.
Okay? And as the balloon begins to shrink back, because it's, well, wouldn't have to shrink. It just has to be closed. But if it's closed, it will shrink.
Don't look at me. I'm not an astrophysicist.
So, the cosmic microwave background.
Right.
We have done some experiments to test for this.
Oh.
So, the microwave background is in every direction.
Right.
So, if you look this way and you get an exact, so I know exactly the patterning that's happening there.
Mm-hmm.
And then you just look that way.
Turn around. Right.
Is that exact pattern?
Same pattern.
Because if that's the thing, then that means they are the same place.
Right.
That means that was a line that went around and met on the other side.
Right.
Okay? We haven't found that.
We haven't?
No.
Oh.
But we've looked.
We've
That's
looked.
my point.
Gotcha.
We've looked very carefully for statistically significant repeated patterns
Gotcha.
all throughout the cosmic microwave.
Gotcha. Okay.
Yeah.
Okay.
So that's the best I can answer that.
No, that's a great
But
answer.
Jana might have come in with some more teeth in that answer.
Well, yeah,
Yeah.
leave it to Jana.
Yeah.
You know,
Mhm.
she's always a mind blower. That's very cool.
Mhm.
All right, this is Igor Vihanek.
Igor, this is not Young Frankenstein.
Okay, Igor.
I think in Young Frankenstein, he's Igor.
He's Igor. But he's also Marty Feldman, who has big, giant bug eyes. So I think they were. Anyway,
Igor.
he says, hello, gentlemen.
And is he Dr. Frankenstein?
Right. Dr.
Yeah.
Frankenstein.
But I thought IE is an E and EI is an I. Yeah, Einstein.
Oh, Einstein.
EI, and
Right.
IE is an E.
I don't.
You didn't know that? You never heard that?
Listen, I can barely get I before E except after C.
And
okay?
except in Neil.
Right.
And except in science. And except in Keith. Yeah, so I think they got rid of that rule.
And I spell all those words wrong.
I think they got.
I'm not even lying.
They got. Yeah.
Okay.
I'm an exception to that rule, and so is a whole lot of boatload of other words.
All right, here we go. He says, hey, gentlemen, my name is Igor from Zagreb, Croatia. I'm a first-time caller.
No, I like what he did there. That's good.
Excellent. He says, I've always wondered if there are higher dimensions. Could the expansion of the universe be caused by space-time falling into another dimension? Like if our 3D space was a waterfall falling into a higher dimension and we simply perceive it as expanding in all directions. What would it mean for dark energy? Thank you.
Man.
Interesting.
Damn.
First of all, let me just tell you, Igor, I do not know what kind of weed you are smoking in Croatia.
Stop.
But that is, please.
Send some here.
Yes, send us some of that Croatian weed over here. Go ahead. What a weird concept of our space-time.
So here's the thing.
Falling into another dimension.
Right. There's no evidence that one dimension is susceptible to another dimension in that way.
Correct.
So,
I
for
see what
example,
you're saying.
let's take the surface of a table.
Right.
How many dimensions is that?
That's two.
Two. It just has a length and a width.
Right.
No depth.
No depth.
And then I have another surface of a table. So I can make that table infinite, right?
Correct.
Now I can have another table that's separated from it that's also infinite.
And they're just running parallel.
They're just running parallel, and they're not. There's no one.
Yeah, there's no interaction.
And it's in a third dimension, and there's no. I can embed a two-dimensional surface in 3 dimensions, and it'll just sit there as 2 dimensions.
As 2 dimensions.
It's
inside of a 3-dimensional.
Inside of a 3-dimensional
medium.
It's not calling to you.
Right.
Okay. But here is something that's related.
Okay.
Again, it's not exactly answering the question, but it addresses the question.
All right, that's good.
All right. In our world, we have quantum physics where a lot of mysterious things happen. It's not mathematically mysterious, it's just intellectually mysterious.
Mm-hmm.
Particles pop in and out of existence.
Right.
Matter and energy are equivalent.
Particles behave in the same way over large
they're
periods.
entangled. You know,
Yeah.
there's weirdness that's going on. We can describe it mathematically, though. Is that weirdness completely normal in a higher dimension? Let's just ask for that. So what would be an example? let's go back to our 2D world,
Mm-hmm.
okay? And we're there, we're walking around, or slithering around, however 2D people get around.
We're line drawing.
Yeah, we're only our perimeters to each other.
Yeah.
Right. Suppose we're looking around and we see a dot.
Right.
It just came out of nowhere.
Yes.
It's like particles popping into existence. It's a dot. Where'd that come from? I don't know.
Right.
And then we keep watching. We study it. We're scientists. We study it. And the dot becomes a circle. And the circle grows. And we say, and we're studying it. We're making measurements. Then it grows to like a maximum point. And then it starts shrinking back. And it gets smaller and smaller. Then it's a dot. Then it disappears.
Wow.
We be coming up with all kinds of theories, right?
Aliens.
Aliens.
Because we live in rural America, where the rural part of the paper.
City people. Rural.
We're in the rural part of the paper.
Of the two-dimensional.
Where the two-dimensional, where the dot. Tell you, I was out in the middle of the night. Dot showed up. Got bigger and bigger. Okay, go ahead.
So we can't explain that.
Right.
We don't understand it.
Right.
And is it like studying the elephant, but you don't see the whole elephant?
Yeah, okay.
You get 7 different descriptions: the trunk, the tusk,
Right.
the
tail.
leg, the toenails,
Right.
the tail,
Right.
the side.
Mm-hmm.
None of those comport until you take a step back and say you're all describing the same creature. Okay, and that's the full understanding that no one gets at first. Do you know what I just described?
A hole.
No. I described a sphere
Passing through the paper.
The paper.
Because at one point, it's just a dot because it's a single point of the sphere that's touching the two-dimensional plane.
Exactly.
But as you continue to move the sphere through, then what you have is more points in the 360-degree sphere that keep fanning out, but only in 2 dimensions, so they make a hole that keeps getting bigger
They make
and
a
bigger.
circle.
A circle, and then...
And how big does the circle get?
Whatever the size of the
diameter of
and
the
then
sphere.
you come back, and then you're down 1 point
And
again.
here we are mysteriously inventing forces and phenomenon, and it's just a normal...
Wow.
It's just a normal sphere.
Wow.
In the higher dimension of this example, which is 3 dimensions.
But to us,
to 2-dimensional people...
in rural paper stand.
Paper stand.
In rural paper stand. That was a serious phenomenon.
It was a serious one. And they're reporting that to the government.
Right.
And people are trying to capture the next one.
Oh, wow. That's great.
So if higher dimensions pass through or otherwise interact, it can be very mysterious.
It could be right. Wow. Dude, what a great question.
So he was trying to account for the dark energy. I don't know what could be happening in a higher dimension to manifest in our dimensionality as dark energy.
Right.
That could be a thing.
Right, it could be. Yeah. All right, this is Nat Woods who says, "G'day, Professor Tyson and Lord Nice. Adelaide here from Australia." That was the best I could do, guys.
That's pretty good.
I tried.
That's good. Not as good as your French accent.
No, but I tried.
Okay. Or your gumbo accent. But.
Yeah. He said, "I was wondering if we can't ever truly touch anything, could the space between particles be dark matter pulling the particles together or dark energy repulsing the particles?" Well, there's another thing pulls particles. But anyway, I enjoy every podcast.
Don't editorialize on the man's question.
I was thinking out loud. I'm
Okay.
sorry, and I'm sorry, Nat. I enjoy every podcast, and I remain inspired by you guys every day. Please keep up the good work. Anyway.
Excellent.
Go
Okay.
ahead. You answer.
Are you choosing those because people say nice things about you in each one?
I have no idea. Well, I've never seen this.
Okay.
I should not say that. No, I would never do that.
He's paid to read them in advance.
No,
let the record show.
Exactly.
Okay, so
Go ahead.
So I forgot the question.
So he's basically saying, like, if we can never touch anything, truly, then could it be dark matter in between the touching that's pushing or pulling?
All right. So it turns out dark matter does not interact with itself as potently as regular matter does.
Interesting.
Okay. So when regular matter gets together,
Right.
Its molecules grab on.
Yeah.
It makes solid
All
objects,
kinds of things.
like liquid, gas. It'll make So we have regular matter planets.
Right.
We have rocks because that's what regular matter does, using the electromagnetic force. In case you were wondering. All right, dark matter, what we call dark matter, which is really dark gravity, does not respond to the electromagnetic force
At all.
at all.
Doesn't interact.
Doesn't interact.
Okay.
So it doesn't interact with us that
Right.
way,
Okay.
nor does it interact with itself that way. It does interact gravitationally, though. So you can have pockets of dark matter out there, but nowhere is it so dense that you have solid objects.
Wow.
As far as we can tell, there's no solid dark matter out there.
Okay.
By the way, if it did exist, it would just pass through you because it doesn't
Well,
interact.
it doesn't interact anyway.
With any force that's
Right.
holding you together,
Right.
it's got another instruction set.
Let it slip right through my hands.
So particles, we already have accounted for their behavior with the forces that are known.
Right.
There's nothing mysterious there. Now, he might have known that we don't actually touch things because there was an episode of Cosmos where we did that.
Mm-hmm.
Where as you bring two things together, you feel like you're touching, but what's happening is the electromagnetic forces are repelling each other, and you're responding to the forces thinking that it's a solid thing, but it's not.
And that is why you have 4-year-olds all over the world in the back of cars going, I'm not touching you. I'm not touching you. I'm not touching you.
Okay.
I'm not touching you.
All
All
right.
right, here we go.
Next up.
This is Stetson. And Stetson says, hello,
Stetson got, there's like Madonna. This
yes,
is just Stetson.
That's all he
Cher.
is. He's
Stetson.
He's
Fine.
just Stetson. He says, hello, Dr. Tyson and Lord Nice. Stetson here from the U.S., but currently living in Japan. Well, yes, konnichiwa. He says, the study of planets, including ours, is quite fascinating. The internal structure of our planet is generally agreed upon, but how would we be able to understand the internal structure of other planets, even those nearby?
Great question. Great question. So we make educated guesses and then we test the guess.
Ooh, we making this up.
No, that's not what I said.
We just making it up
It's
as
not
we go
what you
along. Oh my God.
That is
Breaking news. Breaking news.
All right, let's take.
Go ahead.
Let's take Mercury,
Okay, Mercury.
for example.
Okay.
Okay. Mercury is tiny.
Right. Very small. And,
Small.
And
Okay.
closest to the sun, right?
Oh, yeah, it's the closest
The
planet.
closest. Okay.
In fact, our moon might even be bigger than Mercury.
What?
Yeah.
I didn't
Okay.
know that.
I have to check that, but it's
It's small.
small.
Okay.
Okay. But it's a full up legit planet.
Okay.
Well, what's going on? Well, we can measure its mass. Its mass is way higher than it could possibly be if Mercury was composed only of rock, like the moon. The moon is made of rock through and through. Mercury, it has much more mass. So we go to the periodic table of elements and we say, here's the birth ingredients of the solar system.
Wow.
We know that because that's what the sun is made of. That's what Jupiter's. Jupiter didn't give up any mass that it was born with. So you look at the composition on Jupiter, it matches that of the sun. Okay. Anybody else who's different, you've been horse trading your ingredients along the way. All right. So
Jupiter was trying to be the sun.
it's true. Yeah.
That's what Jupiter was trying. Jupiter was just like, I'm going to get one day.
In fact, Jupiter is the only planet that radiates more energy than it receives from the sun.
Oh, I didn't know that.
That's how wannabe it was.
That's how wannabe sun it was.
Yeah, it still does. It's
that's-
still radiating. All right.
That's a great factoid. Go ahead.
So I go to the periodic table and I say, of all these elements, some are very rare, some are not basically not really in the solar system. So I'm going to ignore those. And which are common. And so nickel, iron, these are pretty common in the universe. So maybe I get the mass of Mercury fitting into that volume by throwing in something heavier than rock. Because we know it's rock on the surface because we see the cratering. Looks just like the surface of the moon. Okay?
Right.
So, but deep inside, what could be there? Now, we know when it formed, heavy stuff goes to the middle because it's a fluid thing. It's molten.
Right.
If you're molten and you're heavy, you're going to sink.
Right.
You're going to sink. Okay. So we ask ourselves, how much iron has to be there to give us that
kind of mass?
to get that mass at that size, which is basically the density.
Right.
So the average density, we construct the average density of the object pulling from the periodic table of elements we know are in the universe. So we find out it has a huge core of iron.
That's dope.
It's dope.
That is dope. Okay. God damn it. That is science right there, buddy.
Oh, it works the other way too.
Really?
We've discovered asteroids, okay? And we know they're rocky, but we look at the density, and it's like, these are way less dense than rock.
Rock, right.
Less dense.
Right.
What's going on?
Oh, that's so cool.
What's going on? Because you see the volume of it, and it's a fuzzy image. You know, we're not looking, these are not missions that go there.
It's not like we got binoculars.
Right.
Harold, look at this asteroid.
Where'd you get Harold from?
I don't know. Anyway, go ahead.
I know Harold and the purple crayon, because Harold went into the sky with his purple crayon.
There you go.
So, I liked Harold.
It's a
when I was a
great,
kid.
great, yeah, everybody does.
So, how do you have rock that has less mass than rock?
It ain't rock.
What? Well, it's got to be made out of stuff that we know about.
Right.
So that was the first idea that maybe some asteroids are piles of rubble.
Nice.
So that there's...
So they're coalesced, but they're not stuck
they're
together.
not stuck together.
Wow.
So when we look at the total mass and the total size, the volume, some of that volume is taken up by nothing.
Right.
Confounding our deduction for what its density is.
Like a floating ball of pebbles.
Pebbles.
There'd
That's
be
right.
so much space in between each pebble that floating ball would never have the density of a rock.
Overall density is lower than rock. So that matters because we want to deflect an asteroid. You can't just go up to it and push on it if it's a rubble pop, because
now you got a bunch of little rocks coming your way.
Because
Bruce Willis, you messed up bad.
So you get to push off a chunk of it, and the rest doesn't. It's not attached.
Exactly.
If it's not attached, you didn't have any effect on it.
Right.
So these density estimates are a major part of what folks in the solar system do.
Super cool, man.
So Mercury's small. It's the smallest planet.
Right.
A title formerly held by
Pluto. Poor Pluto.
Why do you got to sigh like that?
Because,
You in my office, there's no sympathy for Pluto in my office.
I know, but you're like Kendrick and Drake. I mean, you won. You won. Why you got to beat the guy up?
Okay.
But go ahead.
Okay, so Mercury and the moon are about the same size. Mercury might be a little bigger. However, Mercury has 4 times the mass of our moon.
Wow.
Same size, 4 times the mass.
4 times the
And
mass.
we know it's rocky on the surface because they both have equal-looking features on the surface. So what's going on?
Right.
We know the moon has hardly any iron.
Right.
Because it was side-swiped off of Earth's crust from the...
It's crusty, baby.
It's crusty.
That's the moon. The moon is crusty.
So we think iron rests deeply and largely within the center of Mercury. Boosting its total mass relative to other normal objects. So that's how we roll when we make the calculations.
Very cool. All right, let's
Got time for a few more, I think.
Yeah, we got some time. Let's rock and roll here. This is Wesley.
We're getting through these quick.
We are getting through.
We are actually getting this.
so
This is like the most we've done.
And I hope people are recognizing that we're getting to you as quickly as we can. Hello, Dr. Tyson, Lord Nice. I'm Wes from Davenport, Iowa, and I, for one, want to say I appreciate your programming and expertise. It acquires more than you know. No, it requires exactly what we know. We're doing it. Anyway.
It's an expression more than you know.
It really is an expression. I know, and we appreciate it. My question
by the way, Iowa, I used to wrestle.
Go ahead.
Iowa knows wrestlers. Okay?
Iowa?
Iowa.
Yeah, that's because, when you grow up wrestling cows.
Is that what that is?
Yeah, getting in
is
the
that why
ring.
they kick my ass every
getting
time?
in a circle don't mean nothing.
They're hauling calves.
You hauling calves.
Paul, where did I put the calf?
Exactly.
Put it over there.
Where do I put this? In that chute over there, dummy. Yeah. Anyway.
Iowa wrestling, long tradition, long proud tradition
of wrestlers.
Of Iowa, yeah.
Very cool. Yeah. He says, my question is regarding black holes and what happens when they collide. With recent theory enhancements from great minds, is there now mathematical equations that work to model this expected action and reaction? Can we mathematically reproduce the collision of black holes with absolute consistency?
Yes, and because we have the mathematics of it, it's the math that predicted the black hole to begin with.
Right.
So we already had the math.
Yeah.
It's not like here's this object, oh my gosh, how do I describe it? Einstein's general theory of relativity predicted black holes, even though he was anti-black hole. Did you know this?
Yeah, well, he was a racist. They all were back then.
No, he actually wasn't.
No, he wasn't.
No, if you read his Ideas and Opinions, it's a book.
Right. It was Hubble who was the racist.
Yeah, Hubble had issues.
Yeah, he had some issues.
Hubble had issues. When Marian Anderson, after she was denied singing opportunity, she's an opera singer in Constitution Hall, Washington, D.C. Because that was run by the Daughters of the Confederacy. Okay, right. That's when Roosevelt said, you can sing on the steps of the Lincoln Memorial.
Wow.
Okay. Einstein is active around then. This is like the 1930s. And I think it was the 30s. But Roosevelt was president regardless.
Okay.
So it would have been the 30s. We weren't at war yet. And she visited Princeton and visited Einstein on the Princeton campus.
Wow.
Yeah, he was receiving of people who were otherwise well-known but had issues with dealing with, societal issues. Yeah, so he was a very forward-thinking person.
Very cool. Well, yeah. I mean, it's great to see that, being how he was so brilliant.
Yeah, but also, I mean, as a Jew escaping the rise of Nazi Germany.
He had some motivation.
Yeah, he had, and some empathetic
behaviors, because, that makes sense. Yeah. Yeah, and he predicted gravity waves. I mean, gravitational waves, which means that the math was already there.
Math was already there, right. And so math was in place, and then we say that must be, but he did not believe that matter would be so, he didn't think the universe would be that mean to matter.
Really?
Yeah.
Interesting.
Yeah. The matter is closing in on itself.
Right.
And it collapses with nothing to stop it.
Exactly.
Down to a singularity.
Yes. It doesn't make any sense.
It doesn't make any sense.
All.
So he said it must be. It can't be.
Right. It can't be.
And then we have been up there and finding black holes.
Look at that.
We got them.
That's so crazy.
So yes, it can be completely described. And what's interesting about it is the two black holes enter each other's event horizon. That's where it gets fun.
Oh, really?
Yeah.
What if there isn't a dominant black hole? What if they are both mirror identities? What happens then?
Oh, you're imagining in most scenarios, one black hole is like dominant.
Yeah, one black hole is just like, you in my part of space now.
And I'm hungry.
Right. So I got news for you. We're going to be one black hole, but it's going to be me.
Did you one time imitate a black hole eating a... No, you had some voice. What was that?
No, what did I do?
It was something.
Oh, no, because I was said black holes are just like, hey.
That is exactly what they would sound like.
Oh, my goodness.
If they spoke English and if sound could move through space, that's what they'd be saying.
Another black hole, a tasty snack. Okay.
So...
Yeah, but that's my concept is that one of them would be dominant always.
But the math doesn't care.
Okay.
Math doesn't. What is bigger, smaller, equal?
Doesn't make a difference.
Here's the thing: when they merge, you have a new black hole that is exactly the mass of the two of them summed together.
Oh, and that's all that counts.
That's all that counts. And then you have a bigger black hole. There you go.
You think we're new, but we're not new. This is Jarrett Higbee, who says, greeting Dr. Tyson and Lord Chucky Baby. This is Jarrett Higbee from Alamo, Nevada. Is the north and south sides of a magnet actually different in any way outside of the attraction and repelling effects? How would you determine which side of a magnet is which? Interesting.
Okay.
So you don't have anything to go on because you can't turn them and attract or turn them and repel. You have to determine which one is north and which one is south.
It is completely arbitrary.
Really?
Yes.
Do tell.
Okay. I will. What I mean by arbitrary, it's that we all decide what to agree on, and then that's the answer. It's not a fundamental thing in the universe that tells, this is north. That's
right. I got you.
There's no whispering secret force operating on this. So, by definition, now think this, remember, like poles will do what?
They repel.
Repel, and opposite poles attract.
Okay.
So, by definition, if you have, let's say, a bar magnet, because it'll work better.
It's easier.
And you hold it with a string in the middle, and it'll turn. The part that points north on Earth is the north pole of the magnet.
And that's it.
You just have to do that once, and that'll set all the other magnets
And
straight.
every other magnet is just like, that's it.
That's it.
It's been decided, guys.
That's right.
There's no need to make a choice.
It's been decided
It's been
for us
decided for
by
us.
that one. Okay, so now what that means is if the North Pole of your magnet is pointing to the North Pole of the Earth, where is the Earth's south magnetic pole?
Wait a minute. The North Pole of the magnet
Yes.
is pointed towards the North Pole of the Earth.
What attracted it?
The south magnetic.
No, come back, Chuck. I need you.
That's insane. The North Pole is the South Pole.
Yes. On Earth.
Oh, my God. That is effing ridiculous.
Yeah.
Oh, jeez.
You didn't know that?
No, man. That's crazy.
Have you thought about that?
No.
How do we call it our North Pole, and North magnets point to it. Now you point a North Pole to a North Pole, and it repels.
Exactly.
Something's going on there.
Wow. That's crazy.
Yes, Earth's south magnetic pole is in our
the North Pole.
Yes.
That's insane. I don't know what to believe anymore. I can't believe anything anymore.
Okay, so now, why? We had someone ask from down under. You can ask, what makes that the North Pole of the Earth at all?
Right.
Was that arbitrary?
Was that arbitrary as well?
Okay.
Yeah, because from where we're sitting.
Well, the folks in the South Pole, they might have another opinion on the matter.
Exactly.
Okay.
Exactly.
That's another one.
Crikey. Anyway.
That's another one that's decided by decree. Okay?
Arbitrary consensus.
Okay. And you know how we get it. You ask, which way is the Earth spinning?
Okay.
Okay. Curl your hand, take your right hand, curl your fingers in the direction Earth is spinning. Now point your thumb up. That's the North Pole.
Yeah, look at that. So that's it.
That's it.
But suppose most people were left-handed then.
There's no left-hand rule. It's only a right-hand rule.
Okay.
Yeah.
And now there's your
And
problem.
plus, most people are not left-handed.
That's my point. We're discriminating against left-handed
I see. So you
people.
think if left people dominated,
if we
it might
were
have been
all
left-handed?
dominantly left-handed, we would probably done it the other way.
Oh, so then the North Pole would have been in the
down,
South.
right.
Yeah, if they did the left-hand rule.
Yeah. Okay.
Yeah. You do that for any rotating object.
Right.
That's how you can say that the planet Uranus is tipped 98 degrees from the vertical.
Oh, okay.
How's that possible if you just have another axis that's up there?
Right.
Because the
It's
right-hand
the
rule
spin. It's the spin.
takes it down below.
That's so cool, man.
Yeah.
That's very cool.
That's how you can have a planet that's 180 degrees flipped.
Right.
Why don't you just say, well, just call that north? No, because the
of the
rotation goes
rotation.
down. Yeah. Okay.
Ooh, that's so cool,
All
man.
right.
All right, here we go.
Good. I think we have time for one more question.
One more.
Or two if I answer each in half the time. I did the math.
All
okay,
right,
go.
Here we go. This is Hugo Dart. He says, hello, Dr. Tyson, Lord Nice. This is Hugo Dart from Rio de Janeiro, Brazil. He says, with my 7-year-old daughter, Olivia, who is a big fan of your show, here's my question. If you had to bet on one breakthrough in astrophysics happening in the next 50 years, what would that one breakthrough be?
We would know for sure whether there was life elsewhere in the solar system, not on Earth.
Cool.
Either in the oceans of Europa or in the soils of Mars.
Right.
Where we think water has gone. We will know for sure whether there is or there is not.
Right.
And if there's not, that's important information.
Very much so.
And if there is, that's even more important.
Right.
I think we'll know that probably in the next 30 years, based on missions that are scheduled. Another question.
So, okay, here we go. This is Logan Sinnett, who says, hello, Dr. Tyson, Lord Nice. This
Logan's
is Logan.
a cool name.
Logan is a cool name.
That is badass.
He says, this is Logan from Phoenix, Arizona here. Have you mentioned that the best telescope discoveries are unexpected discoveries? So I was wondering if the JWST has made any interesting unexpected discoveries thus far, and if so, which one interests you most?
When I was coming up, there was the record for what's the farthest object in the universe.
Okay.
And it's measured by redshift. So, with the letter Z. And there's a mathematical form for that. But the bigger is the Z, the bigger is the farther away the object is.
Okay.
In my day, the farthest objects were Z of 5.
Okay.
When I was coming up in ranks.
Right.
We might have hit 6 when we built the Rose Center. 25 years ago.
Okay.
The farther away it is, the closer back in time it's getting.
To the beginning of the...
Correct.
Right.
But not only that, start from the beginning of the universe, you couldn't make anything until the universe cooled down.
Right.
All right? To the point where matter forms, like atoms form.
Right.
Now we have atoms. Now the atoms can coalesce and make stars. Before they make stars, the universe is still expanding. We call that the Dark Ages. Hasn't made stars yet.
Oh, wow.
Okay? We called it the Dark Ages.
Interesting.
All right? JWST looks around, found galaxies in the Dark Ages. Redshift 14.
Oh, my gosh.
14.
That's crazy.
My head is exploding.
Yeah.
So first, what? A galaxy at redshift 14? Holy shit, okay? A. B, that's in the Dark Ages when it ain't supposed to be.
When it's not supposed to be there. So now we have an incongruency time-wise.
Yes. Or we don't understand how
we
galaxies
just don't understand how galaxies form.
Correct.
Or we had a totally cool dark galaxy. Hey, baby. It's me, your dark galaxy. You can call me the chocolate galaxy if you want.
That's all the time we have.
Yes. That was great.
We got a lot in there.
Man, we got so many questions in.
Okay.
So shut up. No, I'm joking.
This has been StarTalk, Cosmic Queries Edition. Neil deGrasse Tyson, your personal astrophysicist. As always, keep looking up.